Hello everyone. In last lecture we have seen the definition of UPF, LPF and the partition. In this lecture we will study some of the properties of upper sum and lower sum and a numerical question based on the upper sum and lower sum. So let's have the first property which gives a relation between upper sum and lower sum. So let f is function from close interval a comma b to r be a bounded function. Let p be any partition let let p equal to x naught, which is equal to a, less than x1 x2 dot 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 xn equal to b be any partition of close interval a comma b, then your lower sum of f with respect to partition P is always less than equal to upper sum of f with respect to partition P. If you remember, in last lecture we have seen this geometrically. It was very clear uh, geometrically. So now we will prove the mathematically also, because you can see that what LPF means, it is a sum of the rectangles which lies just below the curve, and UPF is nothing but sum of all rectangles, sum of areas of all rectangles which lies just above the curves. So of course that upper sum value, upper sum, it should be very clear that LPF and UPF are number that one should understand. So let me write down, maybe it should be clear that UPF and LPF are a real value, a real number. So LPF is always less than equal to UPF is our target. So let's prove this. It's not difficult to prove. So what I'll define supremum and infimum of a function over the given any sub rectangle xi minus 1 comma xi or sub interval. So P is equal to x naught, which is equal to a, x1 x2 xn is equal to b any partition of close interval a comma b, right? So this is given fact. So now define capital Mi as supremum of my fx such that x belongs to xi minus 1 comma xi, and small mi is equal to infimum of my function fx such that x belongs to xi minus 1 comma xi, right? This is true for all I. So where does I goes? I goes from 1 to n. So This is true for all I, where I goes from 1 to n. Right. Now it should be, it is very clear that sup means its upper bound, this is lower bound of a function over the rectangle. So upper bound is always greater than lower bound. So it's very clear that clearly small mi is always less than equal to capital Mi for all I goes from 1 to n. So now onwards, when I say for all I, it automatically means that I ranges from 1 to n. Now what I'll do, I'll multiply this inequality by xi minus xi minus 1. So let's see what this would imply. Mi into xi minus 1 less than equal to capital Mi into xi minus 1. Now one may ask a question while multiplying either this term is positive or not. If this is positive, then only this will remain, this inequality will remains. Otherwise, if this bracket which I have multiplied, if it is less than 0, then this inequality will be reversed. Now I need to justify whether this is really a positive number. In fact, it is greater than 0. So one can generalize or one can visualize that it's very clear that this xi minus 1 and xi, they are point from the partition. So, and when they are point from the partition has a very nice property. Partition points are always in strictly increasing order. So xi minus 1 is strictly less than xi. That would imply xi minus 1 is strictly greater than 0. So you should note that since xi minus 1 is less than xi, because of partition, since xi minus 1 and xi are a point from the partition, this would imply xi minus 1 is strictly greater than 0. So since this is strictly greater than 0, so this inequality will not change. So even if you multiply this above this part, when I multiply this small mi less than equal to capital Mi, then multiplying this with xi minus 1 will not affect the on the symbol, that inequality. Now this is true for all I. So let me write down. This is true for all I. So m1, that means m1 is less than equal to x1 minus x0 less than equal to m1 capital M1 x1 minus x0. Similarly m2 I is equal to 2, I is equal to 3. So if I add all above n equalities, so this would imply m1 times x1 minus x0 plus m2 times x2 minus x1 plus dot 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 plus mn times xn minus x0. This all is less than equal to, let me write down here only. So this m1 is less than capital M1 times x1 minus x0 plus this second term is less than equal to capital M2 times x1 x2 minus x0. Right. So plus dot dot dot, the last term will be capital Mn xn minus 1 bracket complete. Now this is basically, you could see that this is summation I goes from 1 to n small mi xi minus 1. This is less than equal to summation I goes from 1 to n capital Mi xi minus 1. This would imply, by definition of upper sum and lower sum, this is basically my lower sum of f with respect to partition P, and this is my upper sum of f with respect to partition P. So this completes the theorem that a result that LPF is always less than equal to UPF. Right. So let me take another example. Uh, uh, the example is as follows. Find UPF and LPF for given function. So let me write down. Find UPF and LPF for f of x is equal to x for all x belongs to close interval 0, 1, and the partition P is given as 0, 1 by 4, 1 by 2, 3 by 4, 1. Now you can see that this is a well-defined partition because the starting point and end point is same as your interval point, and these all are the strictly increasing. 0 is less than 1 by 4, 1 by 4 is less than 1 by 2, 1 by 2 is less than 3 by 4, and 3 by 4 is less than 1. So this is well-defined partition, no doubt about it. So the question is find out UPF and LPF. So let's calculate that. So let me draw this function first of all, and this point also. This is my 0. Here somewhere I have half. Here somewhere not half. 1 by 4, 1 by 2, 3 by 4, and 1. Right. And my function is y is equal to x. F of x is equal to x. That means it is a y is equal to x graph, which is a line passing through origin having the slope 45 degrees. Right. So this is what my function is. So let me draw a vertical lines to this. So when I want to find out the upper sum, that time I will form a rectangle above the curve, means above that y is equal to x line. And for the when I want to find out the lower sum, that time I will have the rectangles below the curve. So let me draw rectangles above the curve. So above the curve rectangle I will draw with a red line. So this is what the first rectangle, second rectangle, and 1, 2, 3, 4. So there are 4 rectangles I have. So now I need to find out what is my, because UPF के लिए I need to find out M1, M2, M3, M4. So let me write down that. What is my M1? So my M1 is basically supremum of my function f of x such that x belongs to the first interval, that is first interval 0, 1 by 4. Right. So now which is same as supremum. Now what is my function? My function is basically x only, such that x belongs to 0, 1 by 4. Now you can see that this supremum of this function is straight away, it is 0 to 1 by 4. That's maximum value here in this case. It is 1 by 4 only. And from graph also you can see that this here my supremum occurs. So that point is at 1 by 4 supremum occurs. So 1 by 4, if I evaluate function at 1 by 4, so f of 1 by 4 will give me 1 by 4 only. So my M1 is 1 by 4. Now let me go to the M2. M2 is again supremum of my function f of x such that x belongs to. Now it is 1 by 4 to 1 by 2. 1 by 4 to 1 by 2. And now here my function is again x only, so x belongs to 1 by 4 comma 1 by 2. So this will give me basically my supremum as 1 by 2. M2 is 1 by 2. So you can even geometrically also you can see that at 1 by 2 this is what my maximum value. I will draw the curve by red line. This red line has maximum value, this cross I have done. So that occurs at 1 by 2. So if I draw here, f at 1 by 2 is 1 by 2 only. Right. So now likewise you can see that for the third rectangle it will be 3 by 4 and for the fourth rectangle it is 1. So similarly you can write down M3 is 3 by 4 and 1. So UPF is equal to M1 times x1 minus x0 plus M2 times x2 minus x1 plus M3 times x3 minus x2 plus M4 times x4 minus x3. This will give me as M1 is my 1 by 4 and this is 1 by 4 minus 0 plus, now by the way you may ask what is my x1 x2, these are the points from the partition. This is my x0, this is my x1, this is my x2, this is my x3 and this is my x4, so that should be noted clearly. So M2 is my 1 by 2, is it 1 by 2? M2 is 1 by 2, 1 by 2 times, so 1 by 2 minus 1 by 4 plus 3 by 4, so 3 by 4 minus 1 by 2 plus 1, so 1 minus 3 by 4. This will give me 1 by 60 plus this difference is 1 by 4, so 1 by 8 I will have plus this is 6 minus 4, 2 by 8, 2 by 8 means 1 by 4, so 3 by 16 I will have plus again this difference is 1 by 4, so 1 by 4. So the base is 16 is common, that is LCM, so it is 1 plus 2 plus 3 plus 4, which will be 3 6 I plus 4 10 divided by 16, which is 5 by 8. So my UPF is 5 upon 8. Okay, so let me calculate now LPF. LPF. Okay, now let me draw that diagram. The diagram is very important. 0, 1 by 4, 1 by 2, 3 by 4 and 1. And I have a function like this. Now for lower sum I will use some different colors. So let me use green color. So the curve below the curve, so first rectangle will be here only, it is zeros rectangle. Now here it is, this one, now this one, now this one. Now you can see that here the function has my function curve. This is what my function curve between 0 to 1 by 4, my function curve is this, but rectangles की height to 0 थे, so my small m1 is straight away 0. Similarly for the second rectangle, my curve is this much, but out of this my minimum occurs here, so which is 1 by 4. So it is yeah, so it is at 1 by 4. Similarly for third rectangle it is 1 by 2, and for the fourth rectangle it is 3 by 4. So let me draw m1. So m1 is infimum of my function fx such that x belongs to close interval 0 comma 1 by 4, and this is infimum of x such that x belongs to 0 comma 1 by 4. So this will tell me that m1 is 0 only. On same line, my m2, small m2 will be 1 by 4, small m3 will be 1 by 2, and small m4 is 3 by 4. So now LPF is equal to small m1 x1 minus x0 plus small m2 x2 minus x1 plus small m3 x3 minus x2 plus small m4 x4 minus x3. This is same as for first rectangle it is 0, second rectangle it is 1 by 4, 1 by 4, then x2 minus x1, that is 1 by 2 minus 1 by 4, plus for the third rectangle it is 1 by 2, so 3 by 4 minus 1 by 2, plus third rectangle it is 3 by 4, 1 minus 3 by 4. So this is same as 1 by 4 into, this is 4 minus 2, that is 2 by 8, so that is 1 by 4, plus this is 1 by 4, so this is 1 by 2 into 1 by 2 into this 1 by if I multiply the subtraction of this 6 minus 4, that is 2 by 8, so it is again 1 by 4. Am I correct? It is 6 minus 4, 2 by 8, so it is 1 by 4. That's correct. And plus this is 3 by 4. This difference is again 1 by 4. So you can see that 1 by 16 is again base common, so that 16 is common. So here it is 1 plus 2 plus 3, so that will give me 6 divided by 16, so which is UPF, sorry, LPF 3 divided by 8. So my LPF is 3 divided by 8. So even you can see that my UPF was turned out to be 5 by 8 and LPF was 3 by 8. You can see that this is greater than equal to UPF is greater than equal to LPF. That's it. Now we will have another example. So f of x is equal to x square, where x belongs to close interval 0 comma 1, and the partition is given as Pn, which is 0, 1 by n, 2 by n, 3 by n, dot 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 n by n, which is 1. The question is find limit as n goes to infinity u f comma pn and limit n goes to infinity l p comma maybe I have let me stick with the same symbol. I have used UPF, so UPN comma F and L PN comma F. Right. So well, we know how to. Basically, we have to find out lower sum and upper sum, and then take the limit as n goes to infinity. Okay. So let's find out. We know what is UPNF. So UPNF. This is same as summation I goes from 1 to n 1 to n capital Mi xi minus 1. Okay, so let's find out first upper sum. Now you will observe that distance between any two consecutive terms here 1 by n minus 0 is 1 by n. Now here the distance between 2 by n minus 1 by n is 1 by n. So distance between any two consecutive terms in 1 by n, so here this distance is always 1 by n. You can calculate, but then it's very clear. Now mi, I need to find out mi. Now function is x square. Let's draw the graph of x square. So y is equal to x square is like this. So this is 0, this is 1, somewhere I have 1 by n, 2 by n, 3 by n, so on and so forth. So parallelly we will have a line over here. So if I am talking about the upper sum, then you can see that the first upper sum, so m1 is basically supremum of fx such that x belongs to 0 comma 1 by n. So first interval. So in this case it is same as supremum of f of x is x square such that x belongs to 0 comma 1 by n. So now you can find out this supremum. If x square where x between 0 to 1 by n, the supremum will occur at 1 by n, so it is 1 by n square. So if it occurs at 1 by n, so x square, so it is 1 by n square. And you can even see here at 1 by n, that is the maximum value. So 1 by n f of x is equal to, if I evaluate f of x is equal to x square. So f of 1 by n will be 1 by n square, 1 by n square. So that's very clear. So similarly, m2 will be on the same line. One can generalize. My m2 will be 2 by n whole square. So in general, so m3 will be 3 by n whole square. So I'm not writing this now. You can, I suggest that you should visualize this. So mi will be I by n whole square. Okay, so let me write down now UPNF. So UPNF is summation I goes from 1 to n capital Mi xi minus 1. So which is same as summation I goes from 1 to n I by n whole square xi minus 1, that is always 1 by n, that you can see. This is same as summation I goes from 1 to n I square by n square, and this is 1 by n. So instead of this I will write I square by n cube, which is same as, since n is independent of this I, so I can take this 1 by n cube common. So I will have summation I square I goes from 1 to n. So I got u, p and f as 1 by n cube summation I square, that is basically 1 square plus 2 square plus 3 square plus dot 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 n square. And there is a nice formula which you have studied in your 10th standard, but this is this has a standard formula. Many competitive exams this question will be, this formula helps a lot. So this formula is nothing but n into n plus 1 into 2n plus 1 divided by 6. This is what the summation is. So it is same as, so one of the n will get cancelled, so 1 by 6, I will say it is same as 1 plus 1 by n and 2 plus 1 by n. What I did, 1n I get cancelled with this, and so it becomes n square. So 1n I have taken this n plus n by n, so 1 plus 1 by n, and the another n I have taken with the 2n by 1, so this is 2 plus 1 by n. So this is my u, p and f, and then limit as n goes to infinity, u, p and f is equal to limit as n goes to infinity 1 by 6, 1 plus 1 by n, 2 plus 1 by n. Limit of a into b is same as limit a into limit b. So this is same as 1 by 6 times limit as n goes to infinity 1 plus 1 by n, and limit as n goes to infinity 2 plus 1 by n. This will give me 1 by 6. This limit is 1 plus 0 and this limit is 2 plus 0. So basically I have 1 by 6 into 1 into 2, so this is 2. So I will left with 1 by 3. So at last my limit as n goes to infinity, u, p and f turn out to be 1 by 3. Right. Now similarly I need to find out L, P and F. So let me go for the again a diagram. This is 0, 1 by n, 2 by n, 3 by n, dot dot dot, here n by n, which is 1 from 0 to 1. F of x is equal to x square is a parabola basically. I hope I am diagram of a parabola. Let me draw it in a nice way because it gives a very nice parabola. At a 1 is equal to 1, it is 1 only. Now this time I am taking the rectangle down. Now I need to take, for the first one it is no rectangle, for the second one this, now for third one this. Now you can see that my, for the down my infimum is here only. For the second time my infimum of function between 1 by n to 2 by n, this green curve I have to see. So you can see that, let me write down that small m1 is equal to infimum of fx. Fx is x square such that x belongs to 0 to 1 by n. Now I have to check the x square, means here only that green line I have. So in this, not this, I'm sorry, let me erase this, which one I wanted. Let me draw this with a green line. So basically I'm writing a green, my curve green, that green curve, and this my rectangle is, there is no rectangle. So in this my green curve has minimum value at here only, so that is 0 only. So you can see this is 0. Similarly m2 is equal to infimum of fx is x square such that x belongs to 1 by n comma 2 by n, bracket complete. So I need to check a curve over here. So my minimum value occur at this point, so which I have drawn with the cross, and that corresponds to 1 by n. So it is 1 by n, that means at 1 by n. So x square evaluated at 1 by n will be, it will be 1 by n square. Now you can realize that for the third rectangle, my function has minimum value. If I draw this, then my minimum value occurs at this cross, which is at 2 by n. So 2 by n whole square. So m3 will be m3 will be 2 by n whole square. Similarly, m4 will be 3 by n whole square. So in general, mi will be, you can see for m4 it is 3 by n, for m3 it is 2 by n. So mi will be, it is I minus 1 by n whole square. So u, p and f is equal to limit as n goes to infinity. No, I don't have now limit. I just need to find out the condition. So it is summation I goes from 1 to n small mi into xi minus 1, which is same as summation I goes from 1 to n. Now small mi is I minus 1 by n whole square, and this difference is 1 by n. Now this is 1 by n square and this is 1 by n. So 1 by n square will be common. So I made a mistake here. Let me change that mistake. It should be LPF, not UPF. So LP and F is equal to summation I goes from 1 to n. So 1 by n cube will be common, and it will be I minus 1 whole square. It will be I minus 1 whole square. So this is same as 1 by n cube. How it will be? So initially it will be 1 square or 0 square plus, when n is I is equal to 2, it is 1 square plus 2 square plus dot dot dot. The last term will be n minus 1 whole square, which is same as 1 by n cube. So this has a nice formula. It is n into n plus 1 into 2n plus 1 divided by 6. But I don't have n now, I have n minus 1. So I will say, the formula is, if you remember, we have used formula. Yeah, it is for n, it is n into n plus 1 into 2n plus 1. Now I don't have n, now I have n minus 1. So I will be having n minus 1 into n minus 1 plus 1 into 2 times bracket n minus 1 plus 1 divided by 6. So instead of n, I will have 2n minus 1. So it will be n minus 1 n into, so n minus 1 plus 1 into 2 times n minus 1 plus 1 divided by 6, which is same as 1 by n cube. So this is n minus 1. So this plus 1 minus 1 will get cancelled. So I will have n. Now this is 2n minus 2 plus 1. So 2n minus 2. So it will be 2n minus 1 divided by 6. So one of the n will get cancelled. So I will have n minus 1, 2n minus 1 divided by 6 times n square, so, which is same as 1 by 6. I will take common, and now this is 1 by, so let me take 1 by 6 common, and now here 1 n I will take with this bracket and second one with this bracket. So 1 minus 1 by n and 2 minus 1 by n. So this is my LPNF. So limit as n goes to infinity of LPNF will be, now this is 1 by 6. The limit of this is 1 minus 0. Limit of this will be 2 minus 0. So ultimately 2 by 6, it is 1 by 3. So this is limit as n goes to infinity L, P and F. That's it. Thank you.